NBT World, a vision of Thailand.
Are there life out there elsewhere than Earth? Are we alone in the universe?
No.
Perhaps not, actually. We are also working with friends at NASA to try to design a system of air quality monitoring in Thailand, which will be deployed hopefully in time for the dust season next year.
Swadika, I'm your host Kanakon Ryangsi. Welcome to Thailand Today. In an era where science and technologies are rapidly advancing, the field of Thai astronomy is also gaining increasing attention and significance. From astronomical research and space exploration to inspiring the younger generation, Thailand is making strides in this domain. Today, we'll dive into the challenges and opportunities in advancing Thai astronomy, discuss some exciting upcoming projects, and explore the role of government and private sector support in driving progress. To find out, we speak with Assistant Professor Dr. Wiphu Rujopakarn, Deputy Director of the National Astronomical Research Institute of Thailand. Swadika, thank you for having us today.
Swadika.
First of all, could you please tell me about the core mission of the organization?
Oh, wow, that's a very big question. There are several core missions of the NARID. First of all, as the namesake, astronomical research. We pursue the frontiers of the knowledge of our own universe and to try to understand if we are, for example, if we are alone in this universe, what is at the age of the universe out there. We have used, for example, the James Webb Space Telescope to look at very distant galaxies and also several facilities, several observatories, telescope and space missions to search and characterize exoplanets, the planets that are orbiting other stars apart from the sun. So these are astronomical research to pursue the understanding of our place in the universe. What is the Milky Way like? What is our local neighborhoods like? Is there life elsewhere? So these are all within the realm of the astronomical research. That's the first core mission. The second core mission is technological development because astronomy research requires technologies that are non-existent in any other industries. We have to capture the faintest light from distant galaxies, the faintest radio signals. And this makes astronomy extraordinarily hard. It's a very challenging science because unlike other disciplines in science that you can go out to or grab things into the lab to understand them, astronomy requires us to be stuck here on Earth and try to look out and understand what's going on elsewhere. So this challenge requires, as I've mentioned earlier, us to detect the faintest light, the faintest radio signals. And in doing so, it requires us to develop technologies that are not even imagined by the industries. And that, for example, has driven the innovation of Wi-Fi, has driven the development of digital cameras. And these are the things that provides a very tangential benefit to the society, the technological development that are driven by very difficult questions. The third thing would be the public engagement to tell the exciting stories about the universe to the Thai society and beyond. Public engagement is one of the key mission that is highly visible through the social medias and so on. And I'm here to try to convince you that astronomy is exciting, that it's a worthy endeavor of our taxpayers' investment. And we do other things like serving as an enabler of cooperation and also to transfer the technologies that are invented by astronomy research requirements into the Thai industry. There's a lot more to talk about that, which I trust that you'll be asking more questions later on.
I see. Yeah, so that's all the big missions.
And hence you have asked the big questions.
Yes. So what are the primary areas of research that you're currently working on?
There are several exciting areas of research. For example, I've mentioned earlier about studying very distant galaxies using the James Webb Space Telescope, which is I'm not going to say NASA because it's not just NASA alone. It's NASA in America, ESA in Europe, and also Canadian Space Agency working together to make this brand new space telescope. Current 6.5 meter telescope lying in space 150 million kilometers away from us, so that the light, the heat of the Earth is not interfering with the observation from that telescope. It's a remarkable feat of human endeavor, and the data is mostly public.
Yes.
It belongs to humanity, so anyone on Earth can apply for time on the telescope based on how exciting their proposals are. So at NARIT, we also use, for example, James Webb Space Telescope to look at, to search and characterize very distant galaxies. The reason we're doing that is we wanted to answer the question of how a galaxy like our own home galaxy, the Milky Way, has evolved, has come together in the present form. And in doing so, we could not just look at the Milky Way, just look at, for example, an adult and try to figure out what their childhood are. Yes. Right? It's going to be impossible to do that. Nearly impossible, I would say, because there are several challenging tricks that we're doing. The most straightforward thing would be to look very far into the universe, because when we look further back, further out in the universe, we also look further back in time to the moment, the era where galaxies are still forming. And by looking at several distances from the Earth, we can piece together back what are the evolutionary stages of galaxies from very beginning to their adolescence, so to say, to their adulthood and their present, which we would characterize as a middle-aged universe right now.
Wow.
That is one of the ways we could describe it, because the universe is kind of in a steady state of things right now. It's not forming stars as crazily as 8 billion years ago, for example. Things has calmed down and gone into life starts at 40 kind of thing. So we wanted to study the childhood of the universe. This is one area of studies called galaxies evolution. The other exciting area is to figure out a big question in astronomy as to, are there life out there elsewhere than Earth? Are we alone in the universe?
No.
Perhaps not, actually. Our staff has recently answered this question in a way that I would like to quote her, actually. Her name is Nisha Lito Chawalit. Dr. Nisha has gotten this question of whether we're alone, and she said, no. The next question is, why are you so sure that we're not alone? And the answer is, because we're not special.
Exactly.
Because life here on Earth is a result of a stochastic, statistical occurrence. So if there are enough stars in the universe, it's bound to have life elsewhere. It's just a matter of us finding them. And because we're not special is the big thing here. So to answer that question, we have to first look for planets around other stars. These are called exoplanet or extrasolar planets, because life form could not happen on stars. Stars are thousands of degrees Celsius at their surface, so the stars themselves could not harbor life. Whereas the planets around them, if they're at the right distance from the mother star, that, for example, water could be in the liquid form, this could serve as the platform where life could emerge. And this is the big question right now in the field of trying to find, to search, and to identify where those planets are. This is the first step. It's called the search for exoplanet.
Yes.
The NARID has found 14 of them so far,
14?
out of about 4,000 that the whole world, the whole astronomical community has found. Out of these 14, this is part of humanity's effort to answer this kind of question. And next, after finding them, is to characterize them to see if, for example, water could be present on those planets in liquid form.
Yes.
Because life could not happen on ice or boiling water, so it has to be, or in steam, it has to be in the liquid form that is at the right temperature. At least life in the form that we know about them on Earth requires the planet to be at a certain distance from the mother star. This is called exoplanet characterization. It's also an area that we're doing very intensely. We also working with our international partners to deploy sensors on lunar orbiter, for example. This is ongoing right now. We also work on PM 2.5 because that's one
Yes.
thing that is a thorny problem in Chiang Mai right now. Well, not right now, but it will happen in the next summer. So we're working intensely on that as well. We've developed instrumentation based on the astronomical technology to characterize the level of PM 2.5, and also working on operating the instrument to identify what are the sources of the PM 2.5 exactly, what percentage are from biomass burning, from cars and diesel engine, from industries and other sources, for example. There are many exciting research going on at the NARID, and I think the best way to check it out is actually to come to Chiang Mai and go to visit, for example, our national observatory on the summit of Mount Intanon, and also the giant radio telescope just outside Chiang Mai. Perhaps a couple of days would do the job for the tour.
Wow, that's amazing. This sounds so amazing. So, Dr. Wiphu, let's take a quick break and we'll be back with more of Thailand Today.
The Kingdom of Thailand has so much going on, so much information, so little time to digest. With Newsline, it's all about facts and accuracy. Stay up to date, stay connected with Newsline on NBT and NBT World.
NBT World, a vision of Thailand.
Welcome back. You're watching Thailand Today. We continue our discussion about challenges and opportunities in advancing Thai astronomy. So, Dr. Wiphu, you mentioned a bit earlier about the collaborations. Could you please tell us more about this?
Absolutely. Collaboration near and far is very important in astronomy because there is one universe. We're all looking at the same universe from anywhere on Earth. So everyone in the field is working on the same question, most of the time using the same instrument, same telescope, same methodology. So collaboration internationally or globally is very common in astronomy. So collaboration happens at the level of the scientists with their friends, with people they've met in the graduate schools and at conferences and elsewhere, and also at the government level, depending on what it takes to promote the collaboration. Sometimes it's people gathering in for a beer after a conference, and sometimes it requires an international treaty. So this really depends on the scale that we would like to promote the cooperation. But for example, we are collaborating with I've mentioned earlier about the China National Space Administration on the Chinese mission to deploy scientific payload to orbit the moon and also to land on the surface of the moon. We have also worked with NASA on various things. For example, when earlier this year, when NASA has sent a plane to come to Thailand to figure out what's in the pollution in Thailand, the composition of the pollution. Our staff were also on those flights and conducting the data analysis subsequent to the flight campaign.
Yes.
Because the flight only gathers the data, but the subsequent analysis is what it takes to figure out what exactly is in the air that we're breathing in. So we are also working with friends at NASA to try to design a system of air quality monitoring in Thailand, which will be deployed hopefully in time for the dust season next year, so we can really learn not just how much PM 2.5 is out there, but digging deep down into the composition of the aerosol. What fraction of that comes from burning, from cars, from trucks, from plantations, for example, is one of the research areas that, even though they're very local to Thailand, they require cooperation with pretty much scientists with pretty much on every continent on Earth. So we have to work globally to solve a very local question, even if they're outside astronomy, but in the air quality regime. We work with the folks at the European Southern Observatories, and also many partners in Europe, in France, in Germany, in particular Germany, because of the connection with several Max Planck Institute, for example, in scientific cooperation.
Yes.
In developing the radio telescope in Thailand, we actually have to send our team to radio telescopes in Germany and in Spain to bring back the technology to learn what it takes to operate our own radio telescope. So these are very common in astronomy, and we have to work globally to get our research up to speed here.
Yeah, so there are many collaborations.
Hundreds of collaborators around the globe.
That's amazing. So let's talk about in terms of inspiration to younger generation. How is NORID inspiring the younger generation through its space and astronomy education initiatives?
That is a very important point, because in fact, our existence for a large part of our the history of our institute has been taking that, inspiring the younger generation as the core mission that justifies our existence, because we have served the public in a way that has never happened in the country before. For example, we have at all our sites in Chiang Mai, Songkhla, Nakhon Ratchasima, Khon Kaen, and Cha Cheong Sao this year would have served 1 million on-site visitors in person to look at stars or planetariums or exhibits.
So it's good for locals to visit there as well.
Yes, and actually the entrance is free, and you only I think it's only $1.50 for the planetarium shows, but the exhibit is free. And you, for example, and last year we have organized in collaboration with many partners, an event called Starry Night over Bangkok. It was in late December last year, and over the span of 4 hours in the Benjakiti Park.
Yeah, I enjoyed that.
You did?
Yes.
How cool was that? Because that was the largest star party in the world ever.
Really?
At 12,000 people in the span of 4 hours. And this year it will happen again, I think, on December 7th, because that will coincide with the moment that Jupiter has come closest to the Earth this year. So it's happening this year too. Fingers crossed for the clear sky.
Finger crossed. I would join that for
So
sure.
that is very important that we have served in this year 1 million people on site, and we have so far trained about 6,000 teachers. We have distributed a telescope about this big in diameter and about this long. You can come check it out in Chiang Mai, to about 610 schools so far around the country. So we distributed these telescopes to the network of schools so that they can use the telescope to organize local events with us being their guide. And they have to report what kind of activities are happening. These telescopes are given to the schools on loan because so in this way they don't have to worry about breaking them, because if they kill the telescope, we will fix it for them for free. But if they don't use the telescope, which is the usual thing that happens to equipment in schools in Thailand, people get worried about breaking things because they would be personally liable, and as a result, many instruments are kept nice and unused in their labs. So we wanted to break that cycle and actually encourage people, the teachers and students, to actually use them. And if to the point of destruction, so be it, because that's what it takes to inspire people, to inspire the students, to inspire the community. Because this is very important, we really wanted to get the students interested in STEM as early on as possible, because if you go ask the young kids, it's all they are into are either stars or dinosaurs, and we wanted to get them on stars and dinosaurs for as long as possible before other things in life come take them away. So the further they are in this game, the further they get to form their opinion based on scientific thinking.
Yes.
And our goal is not to get everyone into astronomy. Well, that would saturate our workforce very quickly. But to get the young people to think of things, to look at the world through the lens through the optics of science, of facts, of reason for their whole life as much as possible.
And that will be love it. They love it.
They
for
do.
Sure. Yeah.
So stars and dinosaurs. In fact, the new regional observatory in Khon Kaen will have both stars and dinosaurs. That's in the plan, because Khon Kaen is the capital of the Thai dinosaurs.
Yes.
So
I'm there as well.
In fact, had I have gone digging dinosaurs as I've done earlier this year, back in high school, I may very well not be sitting here, because I actually like dinosaurs a little bit more.
I understand. Everyone loves dinosaurs, actually.
Yeah, so we wanted to use these stars and dinosaurs and other things to keep them in science for as long as possible. And that would be enough. They can go on to become doctors and soldiers and teachers and other cool things out there.
Yes.
But we would still win immensely as a nation if our population look at things through the optics of science.
That's amazing. So just now we talked about the project driven by Narit and also the collaborations. So now let's talk about the support from the government and private sector. So could you please tell us about that?
Well, I could not be more grateful of the support from the Thai government. In fact, this year is the year that we have received the largest level of support in our history, and we're very grateful for that. There are many projects going on. For example, we are building the first Thai-made microsatellite that is going to be ready for launch in 2.5 years. By microsatellite, it means a satellite that is 100 kilogram in mass or in weight.
Yes.
Now that's difficult. Thailand has never done that before. So this is the so-called a project under the so-called the Thai Space Consortium, which is a consortium of 13 institutions within the Thai Ministry of Higher Education, Science, Research and Innovation, or the MASI. We have come together to bring in our strength from various parties in building a satellite that will be designed and manufactured or assembled here in Thailand. And this is exciting. If you go to our clean room in Mariam right now, you will see the model of that satellite right there with a big Thai flag on the clean room wall, just like when you go to NASA and look at their clean room with the American flag on the wall. This is the kind of thing we want to inspire the younger generations, that if you come into these fields of engineering and science, there will be jobs for you in Thailand. There has never been a job like this in Thailand before, but looking into the future, there will. So for example, this is a so-called Thai Space Consortium satellite. Please come check it out. There is, I've mentioned about the scientific instrument that will go orbit the moon in 2026 and in 2028 to the surface of the moon. There is the flagship research programs I've mentioned about using the James Webb Space Telescope and other telescopes to look ever further in the history of the universe and how planets is formed. There is a lot going on about atmospheric science, the air pollution research as well, which I think you hear a lot in the next pollution season.
Yes.
Not because we want the pollution, but it's just that we have worked non-stop from the last season, and the instrumentation takes a while to because there is one manufacturer in the world for this kind of thing. For that instrument on NASA's flight to figure out what's in the PM 2.5, there's only one manufacturer in the world that does this, and we're working with that manufacturer based on our conversation with our NASA friends. So it takes some time. It's not because we want the pollution season to happen again next year. It should not happen again. But we're trying to figure out what will be necessary to drive the public policy to solve this problem. I mean, research underpins the solution to many problems in this country, and we need to get our hands dirty on those research.
Okay, I see. So I heard that there is the project in the pipeline right now, which is Amazing Dark Sky in Thailand.
Oh.
With you collaborate with the Tourism Authority of Thailand. Could you please tell us about that?
In this campaign, we're trying to say that if, for example, resorts and wineries and in Khao Yai, for example, if they stop the light from leaking into the sky, they can actually also sell the dark sky, the stargazing, as their activities. Yes. Some of the hotels and establishments and parks are already doing this. So you apply, and then our team will go there at no cost to advise you what to do with the existing light, and measure the brightness of the sky, and tell you what to do with the existing lights. You have to cap it in certain ways. You have to use yellow light instead of white light because the white light scatters more, for example. Once you make these small adjustments, you can see stars better. And you can use astronomical tourism as a new selling point.
Yes, so unfortunately we now run out of time. Thank you, Dr. Wiphu, and I'm sure there are many projects to come. So make sure you stay updated and follow Facebook page NURIT. And there you have it from Assistant Professor Dr. Wiphu Rujopakarn, Deputy Director of NURIT, telling us about the challenges and opportunities in advancing Thai astronomy. We broadcast every Friday at 11:25 p.m. on NBT THD and every Saturday at 9:30 p.m. on NBT World, as well as live on NBT World YouTube channel. Don't forget to like and comment on Facebook page NBT World. แอมกนกออนเรืองศรีสวัสดีค่ะ
สวัสดีครับ